shear. Okay, in a negative shear. So negative shear it looks like this. Right? That is negative shear. And again, this is our point X. And this is our point Y. Okay, that's so for this case, we know that our shear XY is equal to our shear YX, right? And then stress X and stress Y are both equal to 0. Okay, so now we draw Mohr circle. Okay, we draw, and I want you to compare. Okay. All right. So this is our normal stress. This is our shearing stress. Element rotating clockwise, element rotating anti-clockwise. So now we put our finger on the center again, right? And this is our stress X line and our stress Y line because the normal stress are equal to 0. Can someone tell me point X is going clockwise or anti-clockwise?
Anti-clockwise.
Point X.
Clockwise.
Okay, point X. Right, Y clockwise. Wait, let me. I think it's just misread because you follow this arrow down here. So the element is rotating clockwise. And then point Y is acting anti-clockwise. Okay. So this is point Y. Then you draw your circle. Right? You construct your circle. So you can see is the opposite, right? But you still get the same answer though. Right? Somebody do answer is the same. As I say, if your material is homogeneous, does not matter. But if your material is directional, okay, so directional are what? Carbon fiber. In mechanical or manufacturing engineering is carbon, things like carbon fiber. You need to know the direction, okay? Software to design structures to determine the direction can cost you like the cheapest one I know is about $35,000. You don't need that. You just use what I teach you, okay? And for civil engineers, you need to know the exact direction because that is how you're going to orientate your reinforced steel. Okay, if you don't know which is the best direction and why you don't know also. Okay, so this is why it is important. Okay, there's one thing I need to okay, now there's one thing I want you to focus. Okay, there's one thing I want you to focus. Now, from point X to point Y, what is this angle? Anyone? What is this angle? Anyone can tell me that angle? I know it's a yep.
180.
180 degrees. On Mohr circle, from X to Y is how many degrees? 90 degrees. So there's an interesting trend that we see over here. Okay, so we are going to call this angle theta. Okay, so when that's the case, in the element domain, so I'll write in the center so you can see in the element domain. The angle is theta, right? On Mohr circle, okay, on Mohr circle, right, it is what? 2 theta. So why is this important? Because when you analyze with Mohr circle, you have to bring back to the real world, yes or no? It's like Laplace transform. Time domain, S domain, then you bring it back to time domain, right? Right? So if on Mohr circle is 2 theta, you bring back to the real world, you have to divide by what? You have to divide by 2. Okay, that is important to know. Okay, right. Before we start constructing Mohr circle, anyone, any questions so far? Anyone? Anyone? Any questions so far? I don't.
Professor,
Yes.
the points X and Y, they're just notations, right?
Yeah.
They can be A and B or something.
Yep.
Okay.
Okay. Then I will draw for you the deformation pattern. This thing will deform this way. So this is how your element will deform. This is how. So you can see that the deformation pattern is opposite. Okay. Now, one thing I like to make, a statement that I like to make, I asked this question. I set questions for companies that hire engineers to see how technically inclined or good they are for big corporate companies. Okay. And the most funny question, or most simple, not simple, question I asked is there any difference between positive and negative shear? Okay. So the answer is positive and negative shear are both equal. Okay, equal in terms of uh, stress state situation. So what do I mean? There's no such thing as positive shear is better than negative shear, or negative shear is better than positive shear. Okay, both are the same. Okay, so don't think it's not our bank account, right? Or it's not like tension is better than compression. Depend on the material, right? If it's in compression, right, or is a brittle material, compression is better. If it's a ductile material, also compression is better because it withstand, can withstand higher yielding. Okay, whereas in shear, does not matter. Positive or negative, both have the same good, or both are the same bad. Like for example, concrete. Okay, you put it under shear, what will happen? Both are as bad. As long as shear, both are as bad. Okay, right. Before we go into Mohr circle, we need to understand the rules of a circle. Okay, we need to understand the rules of the circle. Okay, so if you have a protractor, okay, a compass, okay, it's now time to do some exercise with it. Okay, I know we seldom use those mathematical instruments nowadays, but you have good. Okay, let's look at this. So first, I need you all to draw a circle. Okay. Yeah. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay. So this is my circle, and this is my point O, which is the center of my circle. Okay, that's the center of our circle. Then we are going to draw a line. Right, this line will intersect the center of the circle into any point over here. Okay, have to go to the center of the circle. Right, then we are going to pick a point. You can pick any point that you want, does not matter. Okay, I'm going to pick a point over here. Right, then we have point A labeled at this point. This is my point B labeled at this point, and where I pick a point, this is my point C. Okay, that is known as our point C. Okay, so from here, what we are going to do now is we are going to we are going to join. Okay, we're going to join point A to point C. Okay, so we're going to join point A to point C. And then we're going to join point C to point B. Right? And what you realize, right? We are better do a better joining. There is not a very good joining. Okay. So what you realize is this angle is 90 degrees, right? I'm going to pick another point, okay? I'm going to pick another point over here that is known as point D. And I'm going to use a lighter color. Okay, I join them again. No, you know what? I'll not put point D there. I'll put a point D deliberately. Okay, I'm going to choose point D. As I say, deliberately, I'm going to choose point D over here. Okay. So because some of you don't have a protractor, so with this you don't need a protractor. So this is a straight line from here to here, and this is a straight line from here to here. Okay, so this is also 90 degrees. I mean, if I do it properly, it would be 90. Always. Okay, so this is one rule of the circle. So from here, I like to join. Yeah, I would like to join from point C to the center of the circle here. Okay, from point C to the center of the circle. So this is the angle. If I use a protractor to measure, this is alpha. This is also alpha. And over here is equal to 2 alpha. Why is that? Because over from here to here is 180 minus by 2 alpha. Okay. So angle sum of a straight line is 180. That's why it's 2 alpha at the other end. Okay. So this is the rules of the circle. So if I were to measure, I'm going to measure now. I have a protractor that I could use. So this is spot on 20 degrees. Okay. So this is 20. This is 20. And this will be what? 40. So I use my protractor down here. It is bang on 40. Okay. So this is what the rules of the circle. Okay. So this is a rule of the circle that you have to remember. Okay, not remember, you have to know. Okay, because sometimes using Mohr circle, right, you only need 2 points, not 3 points to construct a circle. I repeat again, to know. I mean, in 2D space, yeah, not in 3D. Yeah, in 2D space, you only need two points. Okay, to pinpoint the exact location of the center, or to construct the circle at a specific point. In 3D space, like our GPS, we have to triangulate. Okay, so that's why you need what? 3. You cannot use 2 to find the position where you are, exactly where you are in 3D space. Okay, in 2D space, you only need 2. A lot of people say, no, we need 3. No, 2. Later on, I will show you why 2. You don't need 3. Okay, so from here, we are going to go into example number 1. Okay, so now, 1 hour of yapping. You guys will probably, come on, Eugene, move on. Okay. So example number 1. Okay. So I'm going to draw the element. Now we are going to combine both normal stress and shear stress now. Okay. So this is our element. So this is your point Y. There's your point Y. Hey, yeah, right. Point X. Point Y. Rotation about Z. Okay, but we know that we don't use Z. So this is our element. All right. So that's our element. So we are going to have tensile by 40 megapascal, right? And then we have a compression by 20 megapascal. And then we have a shear. Our shear, let's say we put it at 20 megapascal. Right? So we are going to determine, okay, we're going to determine You're going to determine principal stress.